So we're still going to talk. My right window here is for notes and things. So when I show an example of something, I will put it in my right window if it's important. We're going to talk a little bit about the Unix philosophy. We're also going to talk about how this comes into, I can't spell this word. We're also going to talk about how this comes into play in the actual Unix system. And we're going to talk about why this is important. So the Unix philosophy is, I'm pretty sure I could find it on the internet. There's a quote about it. The gist of it is you have small composable components. That's good try. So you want all these things that you can put together to do more powerful things. Like I can, list all the files in a directory. Wow, I need alias ls equals ls color e equals auto. Wow. Oh yeah, this is BSD. Well, I mean, Mac OS is based on BSD. Ah, there, colors, beautiful. Okay, so you have these smaller tools. This one, it only lists the files in a directory. That's all it does. And then you have other tools like sort, which will sort the inputs. So like BA, done. And it says AB is, the sorted result of this input. And then you have tools like unique, which take A, B, B. And you can see it printed out. Now let's echo A, echo A, echo A, echo B to unique. Okay, so you can see it took the 3 A's and the 1 B, and it gave me an A and a B. And you can also say unique-C for counts. It'll tell you how many there were. So you have all these tools that do nice little things. And they do one thing, and they do it really well, and they are composable. And the reason they're composable is because they all work on plain text input. So you can't take a GUI program that you have and just take some output that the GUI program does, some action, and then just put it into another program that does a different thing. Either the GUI program that you're using can do this other thing that you want, or you're done. That's it, the end. But in a Unix system where everything is composable, you can take the output of one command and pipe it, which is what this guy is. It's called a pipe, into any other command, and that lets you compose these programs together. So that's one of the things I really want to talk about, redirections. So you have pipe, out and in. So I can say, echo, ha 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 ha, Unix is da bomb, right? Which is going to print this out. But then I can redirect that to file, and then it doesn't show anything because it's in file. And then I can also, read that input in with the input redirection, or if I had a program that did something with this, like cut -d space F1 from file. So cut lets you cut apart a piece of text. So this -d sets the delimiter, which means it's going to cut on spaces, and -f is the field number, so it's going to cut out the first field. So I can go back here and do the second one, or the third one. And then there's another utility, tr, which is text replace. So I can say, make all the A's B's, which is not super useful in this instance. So let's write down the commands I've used here. Cut, tr, cat, echo. Okay, so the great thing about this is there's another command called man. And this will give you a manual on how to use all of these utilities. And you can use J and K just like in Vim to go up and down. And you can search color color specified. I can see that word. And so like, say I want to search for a delimiter. Okay. So you can, it tells you how to use these commands. Man. So all of these commands are composable with plain text. And that's the language that they speak, because coincidentally, that's also the language that humans speak. So that's what the Unix system is really, really about. It's about having a conversation with the computer. A GUI interface like a IDE, which is big and clunky. You have this GUI, and like you are able to find like everything that you want to do in these menus, and it is basically like a very large tool that you use via clicking and things, right? So I click around for this and that, and that's how I use this tool. I actually don't want this open anymore. But the Unix command line is all about having a conversation. So with a tool, you don't need to know anything necessarily about how that tool works, which is a big advantage of that, and that's why they're really popular among non-programmers, because you don't have to speak any language to use a tool. It has nice little buttons and other things that like sort of guide you to the functionality you need. You don't have to read a man page to figure out how to play an audio file in an audio player, because there's a big ass play button in the middle of the screen, like play. And there actually is sort of a language in a GUI, which is like why old people have trouble with computers. It's like what like doing a certain thing will do. Like double clicking is supposed to like activate something, or like pressing a button, blah, blah, blah. Like there's a language there, but it's not nearly as complicated as the Unix command line, and it's not nearly as expressive. So like one example that I could do with this is, well, for starters, I can show a history of all the commands that I've ever run, which is a lot of things. So there's a tool for this. On my MacBook, I've run 13,121 commands on the Unix command line. So WC, word count. Only 133. That's not bad. I don't know what grep stands for. Search.
New regular expression.
I don't care at all. Manual pages. Cat and aid files. Text replace. Text cut. Okay, so we can use these composable tools, right? Like we could write a GUI program to tell me like the commands that I've run and how great that is and stuff. Or we can, put some of these tools together. F1. So this is all of the first letter things that I've done, just like straight up the commands, right? And some of these are variables, and so I want to cut those out. So I can use grep, and -v means inversion. So like this will cut out things with equals. See, it's not there anymore. And then I can sort these. So to group them together so that unique can count them. And then I can sort them again based on number. And we can see the command that I run most is vim, followed by git, followed by cd, followed by rm, brew, cat, ls, sudo, move, like a lot of these commands. And we can see like my least used commands are like a lot of like commands that don't exist or typos, like cuff. Like not.
Like that's the same as cut though.
Yeah, so it says that I don't use cut very much. And that's an interesting artifact of the way that we've chosen to do this. So whenever I use cut, like notice, it's not at the beginning. So the way we cut this command is we look for the first space and then only got this thing. So cut is almost always used through a pipe. And so it's not going to show up in that thing. But I think I have a different. History, cut. I think I've done this before. Ooh, I've done a lot of shit with this. Okay, not today. So you could use more Unix commands to like slice on pipes and then like group them together, and so you could get all of your commands. So let's talk about now what pipe actually does. So when you pipe one thing into another, it takes the output of this first command and it sticks it to the input of this one, right? So if I run cat, so cat, as you like over here, cat concatenates files. Does everyone know what concatenate means? Basically means append, puts them together. So if I, like that file I had before, if I put it together 3 times, you know, then it does it like that, right? So if I want to, so then if I take the input of cat, if you do nothing, then it just takes what's called the standard input, which is just typing stuff into the program, and then it cats it back out, right? Okay, so we can use a redirection to make some file, like file, the standard input, or we can like take file as the input to cat and then pipe the output of cat into cat again. So piping through cat is a no-op because it takes the input and it puts it straight back of the output, right? But when you cat through something, or when you pipe through something like cut, like we did here, right? The output of history is going into the input of this cut command, right? And then the output of cut is going into the grep command. And so we can run these just on their own. So grep-v, remember, like it searches for things in the inverse. Instead of keeping only lines that contain something, it keeps only lines that don't contain something. So I can type, you know, haha, and it comes back out. If I type lol, or like I have typed lol, those lines contain lol, so they're being cut out by grep, right? And so, you know, I can echo stuff into it and pipe it through, and it does the exact same thing, right? So that's what this like plain text composability is, and that's why you're having a conversation instead of just like using a tool clicking on buttons, because you have to like be aware of the language. You have to be aware of the words, which is like echo and grep, and you have to be aware of like the grammar, which is basically pipes and redirections and other types of things. Let's go back to bash. Oh, yeah, those are flags, also known as arguments. You'll hear arguments used a lot. Don't know why, but an argument doesn't have anything to do with the typical usage of argument. It means basically a flag or a parameter. So if I say ls or whatever, let's go to a directory that's less full. That's not going to happen. What directories do we even have? Okay, so what? Okay. So the ls command like does a particular thing, but then when I add a flag to it, this flag is -G, -G on BSD or Mac OS X, which is a derivative of BSD, means colorize the output to show the type of the files. So red files are executables, blue files are directories, and white files are plain files. So there are other flags like ls-a, which means show everything, including hidden files, and then like ls-l, which means show a detailed view of the files. So you can see like the last time I modified these files was on April 21st of 2014, and these are all the file sizes in bytes, and like these are the users and owner. So I'm Peter, and I'm in the staff group on my laptop, which makes sense. It's kind of mine. And then these are permissions, and other numbers, which we'll talk about, maybe at another time. And you can combine flags like -l-h. So -l means show details, -h means human readable. And so you can see it changes the sizes to like this many bytes, this many kilobytes, and other stuff. And so that works like all the way up to gigabytes, where we have this movie, which is 4.6 gigs, and this movie, which is only 500 meg, and other stuff like that. Ooh, what's this? Ooh, this is frozen. 1.4 gigs. What's what? Oh, that's a talk about computer science stuff. Where'd it go?
Right, good. You guys know what WAT means?
I lost it.
WAT. Exactly. Let's talk about Ruby. In Ruby, if you reference an undefined variable, of course it name errors as you.
Okay, anyway. We can watch that talk at the end, right? So, and as you saw, he was on a command line, not in a GUI, typing in Ruby stuff and then running it with some button. Ugh, fascists. And then, okay, so we get to, why am I, okay, this is a lot more effort than it should be. Can I just there we go. Okay, so we get to use this interface via a conversation. So why is this important? As a programmer, you will be having deep and meaningful conversations with your computer that last, for days and days, depending on how long you're working on a project, or weeks or months, and it's going to be very important to you to be able to use precise language to talk to your computer. And sometimes, a precise language that a computer understands, for one, is code, but sometimes it's not always a good idea to write code to solve a problem. Like for example, like that searching through my history problem. Like, how many of you want to write this program in C or Java? Jared.
I was like, how would you do this? I'm like, this is 3 lines in bash.
Yeah.
We're not 3 lines, just 3 commands. He's like, yeah, somebody wrote it in Java at one of these interviews. I'm like, Christ.
Yeah, poor sucker. But if you do want to write code on the shell, and if you do need things that need stuff like conditional logic or loops, there's facilities for that. So back to bash, ps1 equals. So you can actually say for a file in all the files in this directory, echo that file. And then the way you end a for is done, right? Do echo. Okay, and so we've just implemented ls in bash right there by iterating over all the files in glob. So globbing is a really useful feature of shells. It basically means fill in this asterisk, or a glob, or a star, or a bang. Not a bang. Bang is different. A splat. I call them stars. With whatever you can fill it with at all. So if I look for star.png, then it shows me all the PNG files that I have. Or I can do things that start with A and end with MP4, right? And that's only one thing. Or what about B? Okay, so nothing. And what this will actually do is it expands this little pattern right here, it's called a pattern, into a bunch of different arguments on the shell, right? So in a GUI, if you select multiple files and then click and then drag them all to a different folder, if I want to do that here, I use the mkdir command, folder, except they're called directories, so let's not do that. MK directory, fancy. So now I can move like all these PNG files to this directory. And so let's echo this first. So this is the command that's going to be run. It gets expanded into this bigger command. So you can see all these PNG files are here, and then directory. So the way the move command works is it moves all the things except for the last thing into the last thing. So if I were to actually do that, and then look into that directory, like that's where they all are, but I don't want them there. So I can move directory star back to here. And so we can see like it's going to expand this, you know, see each of these individual files, right? And it's done. So we can look back in directory and there's nothing, and then we can delete it. So that's like very analogous to the select multiple files and drag them, right? So you can do everything you can with the GUI pretty much on the shell, on the command line. And that's part of why it's so awesome. But you can, so with that was talking about globbing. So back to the for loop file in star do echo file. Done. Okay, so it's like one line of bash to implement ls and like many, many lines of C. Or Java. And you can do other things to these. Like right now we're just echoing the files. So we can do, for all of the PNG files, let's say we want to convert them to JPEGs. So we can like echo convert, pretend there's a command named convert. There actually is. So right, we have this convert file.png to file.png. Okay, so does everyone see like how this imaginary command would sort of work? It would take in the first file and convert it to the second file. So there actually is extra stuff you can do to the file. So here we can use this special syntax with the pound to strip off the, in theory, strip off the PNG. What did I do wrong is now the question. Is this bash? Yes. Now I feel like a moron.
Double hash.
Double hash is longest match. Oh, you know what? This might be an old version of bash. That isn't, there we go. Okay. Better. Let's try that. This is pretty fascist. Oh, I think it's because file is a command. File shows you the type of files. I hope I'm right, otherwise, this is criminal. Oh, does this one at least work? This is awesome. Okay, well there is a text substitution feature in bash, but for some reason it isn't working for me.
Are you trying to echo convert or echo the result of convert?
Just echo out the command that I would be executing at this time. So that's why it echoes in the beginning. Echo doesn't, no, don't do that. It should still do the substitution though. I don't know why it isn't. Oh well. Well, let's see what JPEGs I have now. It shouldn't have done anything. That guy in the corner knew that this worked, but all the rest of you are just waiting for me to do this properly. Well, I got nothing. Sorry about that. Normally that works. Well, let's just grab my history for it. La 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 la. Almost positive I've done this before. That's Ruby. Anyway, if I wanted to, I could look this up in the man page. Hey. Name, subscript name. Yeah. Remove a matching prefix pattern. Ah, yes. So I have it backwards. User.coding dash. That's prefix. Percent is suffix. Okay, there it goes. You see how in the second ones it's all chopped off, the PNG at the end? So now I can say JPEG here. And these would be converting all of these files to JPEGs. And so I can actually do that. Read image exception. Some of the images got corrupted by my original command. So that's awesome. So we can look at and see JPEG files. Actually. Okay, we can see a lot of these now have JPEG correspondence. It's an alias in fish. Girl.jpg. All right, so I have this JPEG that I've just converted to, and I also have the original PNG, which is the same. And now I could just RM all the JPEGs in here, but I'm pretty sure I have other ones that I don't want to delete. So you can see how I've done this conversion a lot of times. And you can imagine how this might be useful. Like, say you have in your CSC assignments, you have a list of tests, and you want to go for, test in tests, for test in tests, test bang.txt. Yeah.
What does the question mark do?
The question mark is single character glob. So glob matches all of these, will match all of these tests because glob expands to an arbitrary number of characters, but question mark expands to exactly one character because I want to only do these like numbered tests 1 through 5. So I can do this, edit distance, and then I can redirect in from these test files, and it's going to run all my tests right there. And that's much better than typing Java edit distance, tests, test1.txt. Oh, test 2. See how error prone this is? And so you can automate tasks that are tedious. And so I'm actually using a couple of things, right? So I'm using the for loop, and I'm also using an input redirection. So I'm actually, instead of, normally this program reads from standard input, right? So A, B, A, right? But instead, I'm using a file as input. So with the input redirector, right? Does everyone get that? Yes, maybe. I've been talking for like half an hour, and you guys are all probably dead. Does anyone have any questions about any of this? No questions? It hasn't been longer than half an hour. It's been exactly half an hour because I can see the clock. Okay. Anyone have questions? Does anyone not understand things? Any question? This is a trap, but I will take your question.
What's the airspeed velocity of a swallow?
At least 900 kilometers per hour. 900 kilometers per hour.
Velocity of an unladen swallow.
900 kilometers per hour. Surprise. Yes?
What's a good way to learn all of those? Is it just I have this problem, was a command for that, or?
Yeah, that's a good point. If you Google how do I do this on the command line, then Google will tell you. There are actually a number of sites that have specifically exist to tell you these things, like how do I sort things in Bash. And It brings up the man page. Wow. But like, there's a ton of places that will tell you how to do all this. Like, this guy gives a very detailed description of sort. Man, I probably don't know all of these things because it's a lot of time. But then there's a specific command. Ah, yes, super user. No, not super user. Okay. But yeah, there's unix.stackexchange, right? And they will tell you how to do these things. And they will tell you what these mean. And there's that other one. I forget. But there is one site that is particularly dedicated to like really long Unix commands that do something fancy. There are also, interestingly, some Twitter accounts you can follow that have, let's see, that will have like a bash command of the day. Unix tooltip. Right? And so it just says like, yes, here are all these things that you can do with Unix tools. And this Twitter account is my hero. And stuff like that. So, but the big things to take away from this are redirections, either to another program, or to a file, or from a file, right? And these are pretty, tr not so much, no one uses tr. Huh. But like cut, and grep, and word count, and man, and whatever that command I just deleted, cat. These are pretty big Unix commands that you'll see all the time. And of course, you know, ls and mkdir and rmdir and rm and move. So ls being list files, mkdir being make directory, rmdir being remove directory, rm being remove files, mv being move files. I should probably just write those over here. Yeah, cd, mv, ls, rm, mkdir, rmdir.
CD, not CH.
Whatever, close enough.
Also, like diff, when you're specifying a diff with their output,
Oh, yeah.
those are good ones.
Oh, yeah.
Yeah, Vim, I think everyone can, my Palantir reimbursement number is that. So, yeah, you can Vim all sorts of wonderful, good shit. Oh, see, look, I used a glob somewhere. Yeah, I wanted to edit all my test files. So I did that with a Vim on this glob, right? So, yeah. Any questions now, or should I just? Huh? Go.
How do you get started in this? Like, because we see you doing this, but how do you get from I don't know anything about this to like I know how to get it into my IDE and I know how to compile like?
So there are a lot of places. So the big shell that everyone uses is called bash. That's why I kept typing bash, which you cannot see because that is a small letter. And so if you Google how to use bash, then there will be a large number of things for you about how to use bash and how to learn like the shell. Bash is a shell, which there are many types of, at least this many. And you, yeah, Google it, man. Google will teach you a lot, and that's a really big thing that you're going to find in computer science is that you have to self-teach on Google. So better start now. The other thing is nobody is going to teach you the shell, so you should teach yourself. What?
How are you making it autocomplete as you type?
Oh, so that's a feature. This last shell on the list, fish. Fish was the friendly interactive shell, and fish like has colors and other stuff. So like, yeah. So when I type this command, like it's red, so it's not a valid command, but like this actually is a command. And then like you can press tab, do complete through like file names, and
Type fish underscore config.
and it has a GUI interface to change all this shit. And look through your history, which is going to be really tedious to load.
But for those flags that he's talking about, if he goes back
I have 13,000 commands in my history, and I click on that one.
So if you go back in and just type in in your actual fish, in your shell. And then type in something and just do the dash,
What's something?
like cat, and then tap.
Oh.
I mean, yeah, just type the dash and then do tap.
Yeah, so fish can also read man pages. And it will tell you what the different flags on different commands do. So like if we look at ls and we press tab after the command, then it says like -a shows hidden files and -l somewhere down here is the long format. Stuff like that. So it tells you what stuff is. And so I wonder if it's not going to tell me with this because there's too many. But fish does a lot for you. And the way that you tab complete a full command in fish is you press like Control F and it'll tab complete to the full command that you like most recently typed. So like history, and then you can like go upwards and downwards to like the previous commands that match that, right? So there's a lot of cool stuff, huh?
You can hold Alt while you're searching for something too, and it does a different search.
Alt what? What am I doing?
With fish.
Alt up.
It'll find it no matter where.
Oh yeah, okay.
In there.
I see. But we can watch us talk instead.
All right, good. You guys know what WAP?
Okay, so it's 8, so if you want to skedaddle, you can leave, but I'm going to play this because it's hilarious.